Hello everyone. I want to welcome you here. This is our third webinar. And before we start, I just want to make space for people to connect. So I will tell you about our developments connected to Adbian. My name is Alexandra. I'm a member of Adbian's marketing team, and I will guide you through today's Adbinar. I hope you all have a great day, and it's a pleasure to be here with you. Last time we had 32 countries registered to our Adbinar, so I'm glad that it's going well and that you are enjoying it and it's spreading all over the world. So I think now we have space for the news. The most exciting news is that since the last webinar, we finally integrated pooling test into our Adbian analysis, and we are thrilled to extend this offering to a broader audience of tree experts. Over the past 2 years, we've successfully tested our approach on hundreds of trees with great results. So if you're keen to have your polling test evaluated by PhD experts in tree biomechanics, all while enhancing the precision of 3D scanning, simply you can book a call on our website adbian.com, and we can talk about it, or you can, of course, send us an email so we can keep in touch. Currently, we work only with PICAS devices, but we are looking to integrate more manufacturers in coming months. So that should be very soon extended. And more news. Last time we shared with you our community platform, and I would like to tell you that the conversation is already going, and my colleague Eliška is moderating it. As you can see, she is sharing their posts, talking to y'all guys, and there will be much more, so you can definitely connect and join our community to get some news. We can discuss their new features, collecting user feedback, and we also offer exclusive content only to community members. So don't hesitate to connect. I will share with you the link in the chat. I think there it will be the best because I can pin it. You should see it in the chat now, and yeah, it's there. So we're happy to stay in touch with you also through this platform, and also don't forget to stay with us also through social media, where you can like through this QR code you can see our link tree, and there are all social media as Instagram, LinkedIn, Facebook. We have a group there, so I would like to officially welcome you at today's Adbinar with Goran Huljenic and Bara Vojackova. Today's topic is importance of precise geometry in tree biomechanics. Again, my name is Alexandra. I will be here for you in chat, and I will guide you through this experience. And again, we are very grateful for you deciding to spend time with us today. I will quickly go over today's schedule so you know what's coming up. So ladies first, of course, Bara will share with you her presentation named Geometry in Tree Biomechanics. She will be followed by Ondrej Kolarik with his presentation Collecting Geometry Data with Adbian. And third presentation by Goran Huljenic with his case study assessing the stability and ecological value of tree avenue in city of Varaždin, Croatia. Of course, if you have any question, don't hesitate to write them in chat or in the Q&A section. We will definitely get to them after the presentations, and we will have discussions with speakers, and we will answer all of them to you. So if you don't want to remember it, just type it in the chat and we will get back to them after. I think now is time when I will invite our first speaker, Bara Vojackova, to start sharing her presentation. She is interested in tree biomechanics and application of finite element methods, and to understand mechanical tree response to loading, also actively engaged in the field of veteran tree management certification and education process. Hi, Bara, welcome.
Hi, Alex and everybody. Thank you for your introduction. So I have prepared for you. It's like travel in the history. So I would like to go with you through the really basic of the one part of the mechanic which we use in the stability assessment. It's because I think it's important for us because we're still working with this basic. At first, I would like to talk. It's probably for everybody who is here clear our motivation. We all know that the tree brings lots of benefits in the urban areas, and but at the same time, it can be a risk because of the safety necessary in the cities and so on. And also, we know that the trees, when they are growing bigger, the benefits are more valuable for us, but at the same time, the stability of the trees can be a problem when the tree is getting bigger and older and so on. We use the basic methods like visual assessment for tree inventory, and then we make some management plan, and it's for us something like decision tool. And we can start with only the visual assessment, or we can go to the more advanced methods, which are usually for the stability assessment connected with the tree biomechanics. You already definitely saw this. The stability triangle is the typical approach which our engineers use also in the mechanics. So the response of any structure, including trees, is defined by load, material, and geometry. So we can look on the trees from these 3 points of the triangle, or we can look on the tree also on its parts like crown, stem, and roots. But every mechanical analysis requires some simplification. We can simplify every part of the triangle. We can simplify the loads, we can simplify the geometry, and we can simplify also the material, because we are not able to describe the complexity in reality. So we have to go through these simplifications. And the question is how much we can be benevolent in our simplification. Today, we will look on the geometry only, and we look on the what is like the common tool in the stability assessment. And I have to say, it's really simplification of the situation around the tree biomechanics, because we said that we will assess the tree as it is like cantilever beam, which is stick in the ground and which is like bending in the wind. And this is our basic for our calculation and our evaluation of the static of the stability of the tree. Normally or commonly we use the safety factors, like because people, they like numbers, and especially the tree managers, they really like to know if the tree is safe or no. So it's very popular to use the safety factor, which is telling like if the tree is safety enough or not. Today I will be speaking about the safety factors which are used usually in some calculation methods, like we calculate safety factors based on some computation, or sometimes the similar safety factor is used when we are doing the assessment by acoustic tomography. So at the end, we also can get the safety factor, which is based on the similar like principle as the safety factors which are calculated from calculation methods, for example, wind load analysis or SIA method or whatever. The safety factors which we get from the pulling test is kind of different, and probably Goran will speak about it more, so you will hear it later on. The safety factors which are used for the calculation methods or acoustic tomography usually work with some stress that we try to calculate which level of stress is in the stem, which can be like achieved by wind loading, and then we compare this stress with the strength of the wood, like the number which is telling us how big load can be bearing the wood without some permanent deformations. So this is like the really like the basic way of the computation of safety factors. And I would like to today look on you in the detail on the stress which we are calculating in the tree stem. We know that the stress in the tree stem is like complex of several stresses. I assume again that you already see the pictures from Matek, who is telling us that in the tree we can have the compression stresses, bending stresses, which are combining tension and compression, and the growth stresses. Usually in the analysis, we are not working a lot with the growth stresses, but we compute the compression and bending stresses. Maybe I ask one more. If you see the mouse when I'm going around the picture, do you see my mouse?
Yes, we do here.
Oh,
see
perfect.
it.
Yeah, thank you. Thank you. So we compute compression or bending, and today we again will go to the small part, and we just concentrate on the bending and on the geometry parameter from the bending. The stress in bending is calculating as a bending moment, which is applying on the tree, and it's divided by this letter, which is called section modulus. And today I would like to look on you in detail on section modulus, because this is the value which is significantly influence the results of our calculations. As you know, the section modulus is coming from the second moment of area, or we call it sometimes as moment of inertia, because it's based on the similar principle. So the letter which is used for the marking of this second moment of area or moment of inertia is E. And the section modulus is calculated from this moment of inertia, which is doing like the moment of inertia is divided by the maximum distance from the neutral axis. And now I will go into more detail about these two geometry parameters which we are using in our calculations. It's because some authors are working with the moment of inertia and some authors are working with section modulus. So I think it's good to review what is behind these two letters. So this is a little bit from the theory. It's really kind of simplification of the mechanics, but I think it's good for the understanding. So let's see in detail to look what is happening in the tree when it's bending. So when the tree is bending, we use, as I said, the theory of cantilever beam, of bending beam, which is based on the presumption that when the tree is bending, there is some curvature of the tree stem. The curvature is like the 1 divided by the radius of the curvature. And this curvature of bending, the letter key, we use in the calculation of the stress in the tree stem. You can see in the first equation that the stress is basically calculated from the stiffness of material, which we are describing as elastic modulus. This is multiplied by the curvature of the stem, of the bending beam or bending stem. And there is also the importance of the distance in the cross-section area of the stem. So the small epsilon letter is like the marking for the distance from the neutral axis. Before we start, I will talk a little bit about neutral axis. The neutral axis is the axis around which the stem is bending. You definitely hear about this, and you know that when you bend the tree, on one side of the trunk, it's compression, and on the second side of the trunk, it's tension. And in the middle of the trunk, or theoretically in the middle, there is like the zone where is no tension and no compression. And this is what we call the neutral axis. If we have regular stem, the neutral axis is in the middle of the stem. But if the tree is irregular or some geometry is irregular, it's usually the position where it's centroid of the stem or the geometry, and the beam or the stem is bending around this neutral axis. But this axis can be like move a little bit right or left according to the centroid of the body of the stem. We will more talk about the neutral axis later on also, so that's why I wanted to speak here more about it. But definitely we see that for the calculation of the stress, the distance from the neutral axis is also important parameter. So now we are going from this picture, which is on the upper part, to the bottom picture. It's like detail of this part in the bending. So now we can see, like simplifiedly, what is going on in tree stem. So when we are bending the stem, as I said, you already definitely know that on the one side there is compression, on the second side there is tension, and the stress is growing with the distance from the neutral axis. When we want to compute the stress which is in the stem, or we want to compute the level of the stem displacement or how much it bends, we have to compute it for whole area of the stem cross section. And it's good to know that what is going on in the cross section. That's step by step is increasing the force which is acting on the cross section and the bending moment, which is like applying in the cross section. So when we are looking on it, how we calculate the stress, we have to go more into detail. We have to consider the forces which are acting in the stem. The force is acting in each part of the stem cross section, and you see that I have the letter E here, which is like the mark for the infinitesimally small area. So if I this stem divide to lots of small area, the letter for it's like E. So it will be that there is like force 1, force 2, force 3, force 4, and so on. So for each part of the stem, I can compute the force which is acting in this part, and it's giving by the stress and by the area on the which is here for the force to apply on. When I use these formulas to this equation, substitute it, I can get this equation which is telling me that the force is given by is equal to stiffness of the material, the curvature of the stem, the distance from the neutral axis, and the small area on which the force I am computing on is applying. But because we are in the bending, I need to compute the bending moment. We are used to we use commonly the bending moment, which is applying in some cross section. So we usually are commonly using the formula that the bending moments is force multiplied by arm, and we apply the force to the center of gravity of ground, and we multiply it by the arm. So this is like how we commonly calculate the bending moment in some part of the tree. So in the cross section, there is lots of these bending moments acting also in the cross section, and this bending moment is increasing with the arm of the cross section. And we can see that we calculate this like small bending moment, this part we calculate as the force multiplied by the arm. So we multiply force by the distance from the neutral axis again. And because we already solved the force here, and this force multiplied by the arm, we can substitute again the equation. And we now see what's going on here, that the distance is here like in power square. It's like multiplying once more by the arm of by the distance from the neutral axis. So when I compute these small areas of bending moments, these lots of small bending moments acting in the tree, I then can compute something like the total moment, which is like causing the deformation in whole tree stem. And here you can see that for this we use the integral. So we do this like integral of the across the whole cross-section area, where we compute where we use the same equation. So it's like the modulus of elasticity or the stiffness of the material, the curvature of the stem. Then we see that we have to use the distance from the neutral axis, which is squared by 2, and then we apply it on the small area on infinitesimally small area. So it's like the total moment, the total bending moment acting is trees. It's like sum of these small bending moments applying across the whole cross section of the stem. Now we just do the simplification of the equation because the elastic modulus and the curvature is like constant, so we can pull them out from the integral, and here we can see the equation for the moment of inertia, which we used in the calculation of the moment of inertia of irregular cross sections. So we can see that the moment of inertia is like the integral of distances from the neutral axis powered by 2 for infinitesimally small area. So this is the letter E. This moment of inertia is using for the calculation of flexural stiffness. So when we look on the equation for the stiffness of the trunk, so we are interested in how much the trunk can bend, for example, without being like permanently destroyed. So we use usually this equation, which is tell us that we again see the numbers, the letters, the elastic modulus, the curvature, and here is the moment of inertia. So now we look how the letter E, the moment of inertia, is connected to the section modulus. Section modulus, it's telling we use when we want to see what's the maximum stress acting in the stem. And because we know that the maximum stress in the stem is on the edge of the body of the cross section, we just use the equation for the stress analysis and the equation for the stiffness, and we again substitute the equation for the stress analysis with the computation from the equation for the stiffness, and you can see that the stress is computing as a bending moment multiplied by the distance from the neutral axis and divided by the moment of inertia. So when we calculate the stress, maximum stress, or the stress which is acting in the tree, but we are not interested about the like partial stresses, but we are interested about the biggest one. We use this computation, this equation, which is telling us that the bending moment is multiplied by the maximum distance from the neutral axis, and it's divided by the moment of inertia. So it's the same analogy as we can see here, that the second moment of area is like moment of inertia divided by the maximum distance, and this second moment of area we are applying in the computation of the stress acting in the tree stem. So it was kind of the window in the theory behind the section modulus. And why was this important? Important is because we usually use lots of like the primitives for the calculation of the second moment of area, moment of inertia, or for the section modulus. Usually in the calculation methods like wind load analysis or SIA method, we use circle instead of the real shape of the tree stem, or we use circle with the hollow and so on. And we all know these equations, like that the moment of inertia is P multiplied by the radius powered 4 and divided by 4, or when it's a diameter, it's P multiplied by diameter squared powered by 4 and divided by 64. So, and we usually can very well know that the radius, we can see the radius is very important because it's powered by 4. When we use the section modulus, so moment of inertia we will usually use for the computation of stiffness, but for the stress we will use the section modulus, and the section modulus is like only calculate as E divided by the radius of the circle, and we get this known formula that section modulus is equal to PD powered by 3 and divided by 32. So I assume that you all saw this formula for the circle section modulus, and we oftenly use it as an example how geometry is really important, like the diameter, because you can see that here on the graph for Paul that with increasing diameter, the section modulus is growing really exponentially. So small increase in the diameter cause big changes in the stress because it's caused big changes in the section modulus. So here is example again from Paul that you can see when you have smaller stem, the Z is he uses Z for the section modulus. So there is the section modulus, it's about 38,000, and with the bigger stem, but with the bigger cavity, the section modulus is still the same. So it means that the stress in the stem will be still the same, even we can see this as a big hollow, big cavity. So yeah, this is like the basic which I think you already are aware of, but this is like a small window in the history, like that there were some authors which published several like strain cost formulas. It was a tool for the managers, tree managers, or for the tree assessors to assess if the tree is stable or no. In US, they usually use these three approaches, and in Europe, we all probably know the MATEX formula, which is using like the ratio of the thickness of residual and the radius of the stem. So these formulas from Wagner, Coder, and Smiley, they were all like derived from these basic formulas, like from the computation of the moment of inertia. The only difference is that Wagner, he was quite aware of that the tree is not perfect material, so he was like more he was worst for the tree than Coder, who were like more generous to the tree, let's say. So they provide these formulas and say that when you have the diameter of the cavity powered by 3 or 4, and you divide it by the diameter of the stem powered by 3 or 4, depends on the approach, you get something like strain cost formulas. And if this formula is in general higher, the number is higher, the loss is higher than 33% or about 30%, the tree can be considered as a danger. But what is important is that they base these formulas only on the geometry. They didn't involve the material or the load. They just were working with this approach from mechanical engineers. Here is the same, but in graph. So we can see that they said that if the formula gives us number higher than 33, the tree is considered to be hazard. Smiley and coder, they also have here like something like the zone of uncertainty. So that in this zone, it's not sure if the tree is safe or not. And here is when we use it in the graph. So what we can see is on the graph is different approaches, Wagner, Codet, Bartlett, and the one calculate from Kane. And what they are telling us is what is happening with the strength loss criteria when there is some hollow. So I can see, for example, that when I have a hollow which is probably 60% of the stem diameter, so I can see that the coder is like on the 15% of the strength loss. So for him, the tree will be still safe. For Wagner, it's 25%, so it will be so closely to the border. And for the Bartlett, who was counting also with the open cavity, the tree will be unsafe. Here you can see the line with the dots, which is the computation with the Kane. And he was like thinking like, yes, the guys, they are working only with the concentric decay. But what is happening when the decay is not concerning? And he is just one example of what is happening when the decay is not concentric, that the same diameter, like 60% of the stem diameter is cavity. So according Coder, it's still the safe, but when the cavity is offset, it's not in the center in the stem of the stem, the tree can be dangerous because in this case the neutral axis is moving and the moment of inertia is computing in different way formulas. So this is something like the general conclusion from the work of Kane. And for us, I think it's only important. He was just trying it on few trees, and it's he saw what is probably clear, that the methods are underestimating sometimes the thresholds and sometimes is overestimating. So what we know that this really high simplification is really not precise, because the cavity is never in, or it's very rarely like regularly in the center, and it has very rarely some regular shapes. So this work was continuing swiftly, and he was calculating with the offset of the cavity. And here you can see again just few results that when I have again 60% of the cavity in the stem, but I am like moving on the side the cavity. So now we can see what is happening, that it's cost like 20% of the or 15% of the capacity loss on the tangent side, and sorry, I forgot. Yeah, tangent side, and about 30% of capacity loss on the compression side. So we can see that the offset of the cavity, that the cavity is not in the center, can cause like the big difference in the computation of the moment of inertia or section modulus and so on. It can cause the big difference in the stress in the stem computation. So these were the approaches for the, we call it like primitives, like simplified shapes, which we sometimes use for our analysis, maybe in some bigger data set and so on. So it's just good to know that what is going on behind the calculation. But what about the real shapes? What's going on? It's good to know that when we have young tree, the circle can be like quite good enough for our analysis. But when the tree is growing older, it's even more and more complex. The tree is really complicated structure. And with this, the complication of the cross-section of the tree is growing as well. And when we have the complex shape of the cross-section, it's hard to fit some circle on it. So there is the equation of the moment of inertia, which we have been already introducing, which is showing us how we compute the moment of inertia in the irregular section. What does it mean? Like I was already telling that there is an importance of the distance from the neutral axis and that it's multiplying by the small area. What does it mean? It means that with the distance, it's the computation of the moment of inertia growing exponentially. So here you can see on the irregular section, the example just for two parts. I will split the micro section into small rectangles, and the rectangle has the dimension 1 centimeter squared, so it's easy number for us. And now we see what's going on. When I have this dimension, I am computing the part of moment of inertia in this area, and I multiply it. I squared the distance and multiply it by 1. I get the number of moment of inertia by partial, and then I have the second one, and I see there is small difference. There is only few centimeters, but it can be quite big difference in the number E, partial E. And what I do then is that I summarize all these small moments of inertia in one big. So the E increase exponentially as the distance epsilon from the centroid. So usually when I use something like simplification and a circle instead of the real geometry, I can see it can cause me big difference. For example, here, the moment of inertia or the partial moment of inertia will be really different than from this, which is going to the end. Also, I can see that if I use the regular shape, the different shape of the cross section, the centroid will be moving, and so the neutral axis will be moving. So it's again change the distances between the neutral axis and the places which I'm computing. This can be very important with these parts, with the old trees, because the old trees, they have the tendency to optimize themselves to the loading. And when we don't consider these parts where the tree is like optimizing itself, it can be really like deviation from what the tree can really carry on. And last example is, as we look that we simplify, we use the real geometry, but we just simplify. So, but you can see that when I am computing the distances for the outer border, for the surface of the cross section, I can see that I have differences between the real shape and some simplified shape. I use like example this part. So it's like 330. But and here I have something like unprecise. Let's say that I don't have precise picture of cavity. So I make the mistake also in the center of the stem in the cavity, and I use computation for the distance of the cavity edge and for the distance of the higher cavity edge, like two different. And I see that the difference here is only 125. It means that the error, which is now on the increasing from the bed-like outline border of the shape is 2.5 times bigger than in case of the inner, because here I am closer to the neutral axis than on the outer border. It's also tell us that the loss in moment of inertia, which is basic, as we said, for the stress computation, look like increase exponentially with the distance of decay from the centroid. So when the decay is more like far from the centroid, it's more severe for the tree, for the stress analysis. So here is the example from the study which I was showing you, the stems. They were computing the real second moment of area for the they were computing, they were section modulus for the real geometry and for the circles, and you can see the differences here. Sometimes it fits pretty well in some cases when we have very simply like shapes of the trunk, but sometimes the variability is pretty high. I'm probably late, I'm sure. Yeah, I'm sorry about it. So this is just case study. I will finish it with, so I just try to calculate different shapes of the cross section, real cross section, elliptical, circle, and this one is like partially like shape of what will happen if we will have, for example, tomography and we have like only 12 zones. So we can see that there is like some difference in also in the shape and what's happening with the cavity. And I just wanted to show that here I have the real geometry, and here I have the mistake which I was making here by the simulation of picture from tomography. It's about 23%. And when you see, when the cavity is small, in the center, there is no much big difference. But when the cavity is large, there start to be big difference because we are getting on the edge. So the mistake can be even big as a large cavity. So it's good to know that the precise description of outer cross section is important. Of course, it depends on how properly we are doing the analysis. We can use more sensors and so on. So as for example in this study, and also it's good to know that we were now talking about just only one cross section, but of course the stem is like the collection of cross sections. So this is example of whole stem. So you can see what's going on when you have whole cylinder, tapering beam, or when it's real geometry, that the maximum and minimum stresses are really in the different place than in primitives. So at the end, I would like to say that the geometry is really significant. It's significant even for our calculations, but it's significant also for another kinds of analysis. For dynamic analysis, it's really important to have precise geometry. To use the primitives is a good tool, but we should be aware of the limitations. And at the end, the trees are really complex structures, so the mechanics involved also is really complex. So we should be aware of it and try to be more like complex in the mechanics also.
Thank you so much, Bara, for your insights for us here today. And we have questions for you that we will answer in the end. So we will first give space to Ondrej Kolarik. Ondrej's work is centered on using modern technologies to ensure the safety and longevity of trees. He is CEO and co-founder of Arbor Technologies, where he has been focused on product management of our flagship product Adbian for over 3 years now.
Thank you for introduction. I figured that it would be nice to jump in and just to describe, since the geometry is so important, how we work with geometry with Adbian. For those not familiar with the tool, Adbian is a tool for arborists to calculate the things Bara was talking about, so biomechanical stability of trees based on precise geometry. And how we differ from other tools on the market is mostly the precision of the geometry. How we can get it more precise is two reasons. First of them is photography analysis. With each measurement, we collect 5 photos of the tree, inputs from the user, from the arborist who wants to calculate stability of the tree are actually 3 species, 3 coordinates, from which we get the wood material properties and wind zones and coefficients and stuff like that. And from the photos, we are calculating the geometry. With each photo, the user shows us the directions from which he's taking the photo. And with a beam, he's also measuring the distance. So this gives us more data to reconstruct the 3D model. In practice, it works like this. So with each photo, we just measure the crown and the stem. How this differs from typical approach when you take a picture of the tree with a stick, with a measurement like 1 meter or 2 meters a stick, where you then calculate the rest of the geometry, is that we are working with calibrated photographies. That means that you can easily test it on your phone. When you open your phone and camera, you can switch to the fisheye lens and see that if you look through the lens, the objects can have different size depending on where on the displays they are. This is called barrel or pincushion distortion, sorry. And it tells us exactly this, that 1 meter at the base with the pole doesn't mean that the 1 meter here will have same number of pixels. So that's what we are trying to prevent, to get the sizes better. But there are more distortions. For example, just how we came around this distortion. Every user has to do what we call calibration of his camera, because every lens is different. So before you start using the software, you need to take pictures, several pictures of the chessboard from different directions in different parts of your camera, which will tell us how the pictures are distorted, and then we can recalculate it to real geometry. But there are more types of distortion. For example, perspective. So just imagine you are standing below the tree and you are bending a little bit in behind the phone, so it's not perfectly straight. So again, 1 meter at the base doesn't mean 1 meter at the top, same pixel size, but we are saving all 3 axes of how the phone is tilted when you're taking the picture. So this enables us again to get more and better precision data from the photography. And of course, the most interesting tools we are working with right now is 3D scanner. Fortunately, no necessity to buy a device. It's all packed in your phones, because iPhones and iPads Pro started putting LiDAR sensors in there as their hardware. So with this, we can scan trees very fast, like under a minute. Just come to the tree, start scanning, trying to get rid of these colorful points. So it's a very fast process, and the output can look like this. Some studies I saw was looking into the precision, and the error should be below 2% of the real geometry, even with the consumer grade scanners they are putting in the phones. So yeah, based on this precise geometry, we can calculate the real cross sections and the real geometry of the stem very precisely, even with open cavities. If you want to combine it with closed cavities, it's also possible with tomography. as Bara said, I would maybe add that the space between the zones is not the only point where you can get the distortion from reality in case of geometry, because the tomography is building the geometry in some cases oversimplifying it a little bit, which can have a huge effect on the results. For example, in this case, when we overlap the real geometry in the same height as the tomography, we can see that then they don't overlap very precisely. This can be just based on how the tomography software is structuring the results, but also on human error, measuring the distance between the zones and so on. So in this case, it was actually 18% difference in healthy wood calculation, which what Bara said, that with incremental increase in size of the profile, it can exponentially increase the effect on the stability. So that's how we approach to this with Adbian. So yeah, if you are interested in more info, don't hesitate to connect with us. We also will be slowly publishing another webinars where I talk in more detail about this. But yeah, since I saw that there are many new names today, so I figured it would be nice to pop in and describe how we work with the geometry.
Thank you, Ondrej, for your presentation. I think before we will continue with questions connected to your presentation, it would be nice to follow with Goran Huljenic's presentation, who will show us this topic more in practice with his case study. So I would like to ask Goran to start sharing his presentation now, and I will quickly introduce you. Goran is working as a senior researcher in the field of nursery on the position of a leader for the stability of the tree, lecturer and expert on the European Tree Worker certification and other forms of education.
Thank you, Alex, and thank you, Bara and Ondrej, for very nice lectures, and thank you all for having time to listen to my lecture. So we will speak, sorry there was a wrong title. So the last webinar was about the ecological benefits and assessing the stability in city of Varaždin, and now we will look at some comparison with the pooling test results from the projects which we did in Croatia. So quick introduction on myself. I am the owner of the private company Urbani Šumari, and we are a consulting and practicing company in arboriculture in Croatia. I am a VetCert certified veteran specialist. I am a supervisor for the European Arboricultural Council for the European Tree Worker, and also working in the working group Question Bank. And I was and still am part of the working group European Arboricultural Standards in the Erasmus Plus project. And at this moment we are conducting our own project together with the Arboriculture Academy from Czech Republic and EAC on development of digital forms of learning and new certification programs in the field of arboriculture and urban forestry at Southeastern Europe level. Of course, I'm last but not least Adbian user and a very happy one, and that's why I would like to show you our case studies, what we do. So one case study is from the city of Karlovac, where the public institution Natura Viva for management of protected parts of nature invited, or they made a public tender, invited companies who can do the assessment of their trees. We just to give you an overview where this assessment happened. So it happened on this protected tree avenue, which is called Marmontova Alea. It was planted during Napoleon times by Napoleon's General Marmont. That's where it gets its name, and it's Platanus hispanica tree avenue. So in April 2020 to April 2022, there was a big construction site on where these trees are situated, and there were huge excavation workings, and this has heavily damaged the root zone of the trees, and unfortunately there was not much that could be done because these road works were done by a state road company, and they actually, when they announced the project, there is no stopping or adjusting. So we were asked to do the assessment if the trees are still stable. So we did a pulling test of sorry, not all, actually 28 trees that we got from the public institution Natura Viva, that they decided these are the most risky trees because they were following in these 2 years all the works done around the trees. So we did the full visual tree assessment, and you can see here on the right picture how it looks like. So the road surface was renewed, but also the walkway and the driveways to the houses, the bike path, everything was renewed. So the trees were, there was digging around trees from both sides, and the roots were intact in this very narrow zone that you see there is grass. And on the left picture, you can see the results. So these are really severe damages on the root zones. So we were quite afraid what the pulling test will tell us. And in November 2022, we started with the project. We did the pulling test on 28 trees to assess their uprooting resistance and their general stability. One small problem of this project was we had to do it from dusk and then in night, because this is a state road and this is the only possibility how we could do the pulling tests across the road, because for this we had to close the road, not permanently, but like short closures, and this was quite complicated because of state road. So just some basics for you who maybe don't use the pulling test. I will not be thorough as Bara. She had a very, very detailed explanation how we calculate the stability of trees. I will be much more on the basic side of explanation. So basically, when we do the pulling test or the tensile test, we measure the inclination of the root plate. We measure the fiber compression or strain in the fibers of the stem, and we measure the force that we apply to the tree. So these are the three instruments that we use, and we get the data from them into our computer, into our software. Why is this method really good? There are several reasons why we regularly use it. It's the only, let's say, method that we can measure the reaction of the tree under the load, and we can then make it equivalent to the wind gusts. It's a very comprehensive method and very specific. So we don't actually need the wind. We can create the wind load by a winch. We are using it by equivalent wind load, and we draw conclusions about the stability and safety of the tree against the breakage or uprooting without waiting for a storm and big winds. We have a live display of collected data on our computer and in the associated measurement software. We always get asked, what if you overload the tree? What if you uproot the tree? This is not possible. We can really, with the live display, we have overload indicator and even a sound He's telling us if we are putting too much force on the tree. The biggest inclination difference that we put on a tree is 0,15 degrees. So it's really small inclination difference that we put on a tree. Everything is recorded automatically and continuously, all the measured data, and the rope angles is also on the dynamometer is measured, so we get all the relevant information so we can do the calculations later. You already heard the announcement on the beginning of the webinar from Alex. We are also working now with the Adbian software for recording data for pulling test, and it's really great. In the following months, we will do projects that will be with a lot of trees. One project should include like 100 trees, and we will be very, very happy to again report our case study on Adbinar in the future. So just to dive in a little in this project, these are representation of the results we got from the measurements in 2022 in November from the tensile or pulling test. So you see there are 3 safety factors that we calculate from the pulling test. So we calculate the wind throw. So is the tree going to uproot by big winds? We then calculate the trunk fracture or the trunk breakage, if the trunk is going to break when it's loaded by a wind, and we calculate the torsion of the stem, if the stem or trunk is going to be broken by a torsion. And now you see there are some colors which are explained in the text that you can see. So the green ones are okay because if each of these safety factors has to be above 150%. And this is like in construction, you know, there is sometimes safety factor of 10 or safety factor of 7. It depends what you're doing. But in arboriculture, we agreed we accept the safety factor of 1.5. So yes, of course, naturally, if something is standing, then yeah, it's safe at the moment, but we calculate what happens if you apply, if there is a big force of wind applied. So for some trees, you see from the first look, they are under 150, and some of these trees had to be felled because there was no real case how we could save them. And but also we always mark the trees that are borderline, so these trees that are just above 150, and we really like to look into why they are not more safe. And some trees that are just under 150, so we also take special look into them. So we always make explanations, because if we have to fell some trees, it needs to be really good explained why these trees need to be felled. So it's not just, yeah, we calculate the safety factor and that's it. This is just one tool in your toolbox, and every good arborist makes his decision at the end. So yes, we measure things, so we have measurements and data that we have more information, but please don't use the diagnostic instruments and methods that they are not the ones that should decide. You as a consultant should decide at the end what is happening with the tree. So for each tree that was suspicious or needed to be felled, we wrote in the report what needs to be done, and why, and if what could be done. So some of the trees could maybe be really reduced, but they were reduced in the past so badly that the further reductions would just damage them too heavily. And of course, we gave some recommendations on how to work with the soil around the trees, how to do the rehabilitation of the soil and do some soil amendments with watering, so applying some mobile watering solutions, because these trees need all the possible means that we can use to push their root system to develop back. And we also really try to recommend to use the biological agent based on Trichoderma hertzianum, because we have some good results of applying this method for the root remediation. And we are hoping that if the public institution in the city apply this method, then they can push the trees to build new roots and in that way secure their future. So in December 2023, we decided that we will do a reassessment of the trees because they are really severely damaged and we needed to do something with them to further monitor them. So we scanned from 28 trees, 5 were removed because they had no future in that damaged state, and 20 trees we scanned and analyzed with Adbian level 2 and level 3. And we analyzed 7 trees with EML Resi PD 500 because the public institution wanted to know what is with some of the stems, why they showed not so great results on the pulling test. And we analyzed the possibility for root remediation with soil amendments further. So here you can then see after the Adbian analysis of each tree, here you can see the small comparison of results of 23 trees that we did with the pulling test. So on the right side, you see again the same table of pulling test results. And in the left column, you see the results of Adbian safety coefficient calculation, and of course on the far left is the tree numbers. And I was really happy and pleasantly surprised that there was a very nice correlation of the results, more actually than I thought it would be, because you have to take into account that some of these trees, when you see them, when you do the first visual analysis, and if you don't really know what was done to them, you would think these are perfectly healthy trees, and it is not really, if you don't have enough experience, it's not really easy to in the first sight to see that some of these trees could have problems. And we also, of course, did this resistography to prove what is with the stems, and most of them were okay. There was enough sound wood or healthy wood or wood that is still capable of stabilizing the tree, so there is no big problems with the trunks. And the results is that it is very interesting that in correlation where 53.8% of the trees showed similar results when we compare the Adbian analysis with the pulling test. And again, this is really a nice result because the pulling test is really putting the tree under the load. This is really different calculation, but I'm really happy that with Adbian, just so with quick 3D scanning and photo analysis of the tree, we are capable to take more than 50% of the trees and see that they have some stability problem that could be there. So future also problem. The comparison of the results shows that we need to combine the diagnostic methods and tools in such a complex situations. And this is why we are very happy to just Adbian software is a tool that we mostly don't do the tree assessment anymore without it, because just the information that we got from it, it's very quick to do it, and it's I don't want to do any more complex tree assessments without it. And all the results from diagnostic tools and methods are very valuable information for the tree care plan, but it is primary that the consultant can assess what are the results pointing out and to be able to analyze the full scope of the tree situation. And for the future, we plan to conduct many more such comparisons, analysis of our method and tools that we use. One other case study, a shorter one that I would like also to show you, is from city of Zadar. We were again contacted by the city horticulture company Nasadi, and of project of tree assessment and tree preservation. Just for some of you that are maybe connected in the EAC circles, this is the location of the next year AGM, and I would also like to in this way invite you to come this year, sorry, not next year, this year, to this year's AGM in Zadar if you are available. So the area of the assessment is this tree group here in red, in a small city quarter between the buildings. And on the right picture, you can see these trees. These are cedrus trees. And on this here, where you see the cursor of my mouse, is here the tree fell. So you can see on the far left picture, this is a location when one tree fell, and in the past another tree had breakage in the stem, and the citizens actually wanted that this whole group of cedar trees is they need to be felled because they declared them dangerous. And so in the last 3 years, 2 neighboring trees fell, one uprooted and one had stem breakage. And so the citizens were pushing the local horticulture company, and they wanted the arboriculture consultant opinion. So we offered them a solution. Our assessment took place in November 2023, and we did 4 trees VTA, which we record in the Check Trees app, and 3 trees were scanned and analyzed with Adbian level 2 and 1 with Adbian level 3, sorry, and 1 tree with 1 Adbian level 2. And 3 trees were also analyzed in the stem with EML Resi PD 500. This was then request from the horticulture company of City of Zadar. And what are the results? All trees have safety factor above 150. And in the resistography analysis, all trees have intact wood structure. So there is really no need for removal of the trees. And the Adbian results really contain valuable visual and numerical information. So for us, this is really important that because we will have to do a correspondence meeting with all the necessary stakeholders, and we will have to communicate the status of the trees. And with a report for Adbian, this is for us really easy to defend our position. So how does Adbian contribute to our reports? Why, as I said, I really like to use it that much is because it gives really clear visual information, which is important when you work as a consulting arborist and you want to be very clear in your way of communication with your customers and other stakeholders in the that are there for trees. So you see the information. This is, for example, a cavity on a tree. It's very nicely and correctly represented. This geometry is exactly what was on the tree. Then second, we can display the pruning calculation, which is also very important, because often when we write in a report that a reduction of 2 meters, for example, is enough, then people don't believe us, or they want bigger reduction. This is just 2 meters, it's nothing. And actually this reduction, usually you can calculate if it will be enough or not, and how many how much it will improve the safety factor. And this is really powerful for communication. It eliminates the need for pruning out of the fear, which is always over pruning the trees. Then we get the precise geometry presentation and calculation. You had a very detailed presentation from Bara, why this is important. And this is also for us important to know. So which profile you see here, we had 4 pages in the report of various profiles of this tree. So we know exactly at which place the tree is the weakest. So this is also a food for our thoughts. Okay, is it weaker on the stem base or somewhere on, in this example, on 2.70 meters height? So we know how to approach this tree. This is information that you don't get from any other calculation method or instrument. And actually, what I really like, because we are not just consultants, we are also a business company, and this is for us one app solution for clear communication with the customers. So it's really a fast way how you can create some nice addition to your report. So you have the basic tree info already there with the summary of assessment. So the first page really tells you basic information about the tree, and is the tree safe or not, and how much you can improve it with some pruning approach. Also, you get the photo documentation, which is really nicely described and shown. You get the location of the tree and also the axis from which you took the your calibrated photos. So everything is very clear to your customer, how you approach the tree and how you calculated it. We get the wind load analysis, which is a very nice, thorough wind load analysis. So much better than some online solutions that are out there. And the last one is the possibility to fully assess the veteran trees. You saw this tree already in Ondrej's presentation, how he calculates the geometry out of the calibrated pictures that we sent. These are non-calibrated pictures. These were additional pictures that I took from the tree for our report. But as you can see, this is a very complex geometry of the tree, and it's often almost impossible to assess such trees without this method. This really helps us that we can assess veteran trees, special trees, trees that are usually protected, and trees that have a lot of cavities and decays. And this is an example for just a blueprint how the geometry of this tree. So you see, this is a very complex geometry. Yeah, thank you for your attention. And if you have any questions regarding our case studies, you can write us an email, and we will be very glad to answer you all.
Thank you, Goran, so much for your presentation. It was super interesting to see it in practice, and all your cases that you shared with us. I think now is space for the questions. I will start with Bara because there were some, I think, 3 questions for Bara. So yes, hello. I would like to ask you, how do we define the natural axis in veteran trees with a hollow trunk?
Yeah, thank you. Yeah, that's the point that it's very it's kind of difficult in veteran trees. So we have to find the centroid of the shape of the area which we see on the cross section, and then in the centroid we place like the neutral axis. But the problem is how we like orient the neutral axis, because it can be, you know, like this. So we usually use several approaches, or people can use several approaches. The one common is that you find the least generous option, like the worst one, and you use it as a reference, which is not really so perfect, because he usually optimize himself in the direction of the wind load. So the worst option is not the one where the tree is really loaded. So you can try to compare different like orientation of the axis, and and use some options or some ratios. So but yeah, it's kind of like it's not so simple. You have to do the image analysis of the cross section, and then from the centroid you can set up the neutral axis.
Thank you. There are 2 more following questions, I think. If the model applied to veteran and Asian trees with complex morphology, and second one, and what about trunk cavities that are not centrally located? Maybe if you want to add.
Yeah. So I don't know which model. I don't know who was it, but Silan probably.
Yeah.
But I don't know which models you have in mind, because the models like the one from Coder and so on, they definitely are not valid for the veteran trees. It's just for the simple analysis like the circle stemmed trees. Even the popular ratio from Matec is not like applicable for the veteran trees, because it's like more complex. But the computation for the moment of inertia is it can be applied, of course, for the veteran trees, because it's for the irregular shapes. And with the central located cavities, I think I was speaking about it later on in presentation. It's of course has a big influence to the results, and we should be like calculate with this also. So I didn't show the references, but I don't know if the presentation is like we will send the presentation or it's available, or so I can like share with the people the references, because for example the Tsivtsi, he was writing a lot about the asymmetric decay, so it's quite interesting to see.
Yeah, we can definitely share it. So if you will send it to me and I can post it.
Yeah.
Okay, thank you so much for your answers. There is question for Goran now, and that's how were you able to analyze root damage construction with Adbian?
Yeah, sorry if we understood wrongly. So no, you cannot assess or analyze the root damage by construction with Adbian. You can get the information about the trees. You can analyze their geometry, and with the photo analysis, you can analyze their basic geometrical stability. So this is important information, and it was interesting for me to compare this with the pooling test that we did, because of course that's what I said. For these complex situations, you really need to combine the methods. You really need, of course, on a street like this, you cannot just use the Adbian because you really need the real reaction of the tree on the load. But in some other situations where the roots are not damaged like that, you can for sure use Adbian and get some first information, and maybe from this information you can better decide if your client really needs pulling tests or not. I mean, when the roots are not so severely damaged. Because doing pulling test, yes, it's very nice method. You get a lot of information, but on the other hand, it's a time-demanding method, and especially in work sites like this, we are now trying to get the permit to work in one city on these 100 trees, and we are waiting like months for the permit from the state road company. So again, it's the same situations. The roots were severely damaged by the excavation works. We have to do the pulling test. But again, we will compare the data with the data that we collect with the Adbian and just look at this bending moment. How does it does it really have a connection or not for us? So this is really interesting for me to see. And yeah, I hope this answers your question.
Perfect. So I think we answered all the questions. So thank you for all your presentation. I think now I can share with you weighted info about our fourth Adbinar. Our fourth Adbinar will be with Daniel Zanzi, who is co-founder and former president of the ISA Italy chapter, and he has served their industry as a ISA broad director, president of the European Arboricultural Council, and in many other capacities throughout his career. Zanzi founded Phytocouncil, which is a tree care firm, and the topic of our Adbinar will be a 40-year journey through tree stability system in Italy and Europe. He will be joined with his dream team of Phytocouncil, and I will now share with you a link for the registration in the chat, so you can already register and save your space so you will not miss it. And thank you all again for joining us today. I hope you enjoyed it and you gained many valuable information from our speakers. And I am very excited to see you also on the next Adbinar.